Okay, we're going to talk about exponential equations really quick. The basic parent function basically looks like this. Y is equal to 3x. We'll use that as our parent function. There's been nothing applied in a way of a slide or any horizontal or vertical slides on this. It's just y is equal to 3x. And when we graph it, we get an exponential curve graph that looks like this. We call this a growth curve because as we're going across the x-axis and increasing the x-axis, it increases very, very quickly. The features of an exponential graph are the basic parent function of y is equal to anything to the exponent x is always going to cut through 0, 1. And that makes sense because if we substitute in 0 for x, we get 3 to the exponent 0, which is going to be 1. That's 1. And it doesn't matter what that number is. If whatever that number is there, 3 could be 4, could be 6, could be anything. If we put a 0 in for x, we're always going to get 1. So these parent functions, like this, always have a point of 0 and 1. And in this case, it's a growth curve. All right? The other thing you will notice, and I'm going to do a little trick, and I'm going to turn this into a table. Now, this is the same equation, y is equal to 3x. But you'll notice that we've got the 2 in the 9. That makes sense. 3 squared is 9. 3 to the exponent 1 is 3. 3 to the exponent 0 is 1, and so on. Now you'll notice these small numbers. Negative 1 gets small, then negative 2. I could put in a negative 3. I could put in negative 9. And you'll see that the numbers get smaller and smaller and smaller. But it doesn't matter what I put in here for a number in the negative sense. It's going to get smaller and smaller and smaller, but it's never going to hit the x-axis. Y is never going to be 0. Y can't be 0 in a parent function of an exponential function. Okay? So this is the basic features of an exponential graph. A parent function of y is equal to 3x. You've got a point at 0 and 1, and you've got an asymptote at the x-axis. Now, something else that you'll need to be aware of, just get rid of that for the time being, and that, and that. Let's just make y equals, and we'll use a slider, exponent x. And I guess I probably used that somewhere else. Okay, let's make it, can make it any letter. Let's make it S, I don't care. Now, what happens is, as I move this slider, the graph is a growth curve, and then it becomes something quite different, which is called a decay curve. This is called a decay curve because as you go along X, the graph is decreasing. And if you're talking about populations of animals or bacteria, it's decreasing. This is called a decay curve, and you'll notice what the value of the number S, the letter S, the value is 0.4. So it's decay. If I go to 1, it gives me no graph at all, a straight line, but if I go to 1.1, it's now a growth curve. So another feature of the values of a parent exponential graph is that if that base number, in this case it's S, if that is between 0 and 1, it's a decay curve. If it's bigger than 1, it's a growth curve of various steepness. So that's the basic parent functions of an exponential. That's the features. Decay, growth, know when a decay growth curve is. Know that your point of 0 and 1 is always going to be there in a parent function, and that your x-axis is your asymptote.